Okay, students, we are going to now use inverse matrices to solve systems of equations. Last one we did Cramer's rule, which dealt with determinants. Now we're going to use inverse matrices. Okay, the setup and general equation for matrix when you're in matrices is AX equals B. A is called the coefficient matrix, where I take the coefficients of the x and the y's and make a matrix out of it right there. X is called the variable matrix, as we see right here, and so it's times that. And B is called the constant matrix. Right there, I take the constants right there and make a matrix out of them. Okay, so our general setup is always AX equals B. We're solving for X, the variables. So X is not one variable, it's the variable matrix, which in this case is X and Y. Okay, so how do you solve that with matrices? In order to get rid of this A, as you see over here, right here, I need to multiply it by the inverse of A, the inverse matrix of A. What do I do on one side? I have to do on the other side. And with matrices, it matters what side that you put it on. So this inverse matrix is on the left of A, so it must also be on the left of B. It cannot be on the right side of B. You'll get a different answer. Okay, so what we ultimately now have to do, we already know matrix B, the constant matrix is right there. We have to find this inverse matrix. Okay, so then these would cancel out, and that's why you see X equals A inverse B. Okay, your calculator will do all this for you, but we're learning how to do it by hand. Okay, and then I'll show you how you can plug it in your calculator later to check. All right, so how do we find the inverse matrix? Well, here's my rule right here. The inverse matrix equals 1 over the determinant. Remember this AD minus BC, that's the determinant of that coefficient matrix. So this is the coefficient, the determinant of the coefficient matrix. Remember, A is the coefficient matrix. Then, when I take this coefficient matrix, I switch. Remember, the coefficient matrix normally is A, B, C, D. Okay, so but that is not what this shows right here. What do? They switch the D and the A, so they switch those two, and they take the negatives or the opposite of those two, and that matrix goes there. Okay, so that's why you see that. Okay, so that's what that means. Remember, your coefficient matrix is right here, 3, 1, negative 7, 5. But it says I need to switch them, so 5 and 3 switch. That's why you see those switched right there. And you take the opposite of these ones. Opposite of those, that's why you see positive 7 and negative 1 right there. Okay? And then you have 1 over the determinant of the coefficient matrix. Okay, so here, therefore, is my ultimate setup right here to find the inverse. Okay, so going back to my A coefficient matrix, find the determinant. 15 minus a negative 7. 15 minus negative 7 is 22, right? Because negative and negative is positive. So I have 1 over 22 times, and I switch my A and D, so 3, 5 becomes the 5 and 3, take the opposite of those, 7 and negative 1. Okay, now I just multiply that together. So 1 over 22 times each of those, or this is called scalar multiplication. I take some number on the outside, multiply it by a matrix. That's called scalar multiplication. So I have 5 times 1/22 is 5/22. 7 times 1/22 is 7/22. Negative 1 times 1/22 is negative 1/22. And 3 times 1/22 is 3/22. So that right there is my A inverse. I just found A inverse. So now I have to take this answer, my A inverse. That equals A inverse now. Remember, that's this piece right here, A inverse. Now I take that and multiply it by the B, or the constant matrix, and that's what you see right here. And now multiply that by the B. Okay, so now how do you do that? Remember, when you multiply matrices, it's rows by columns. Rows by columns. Okay, so you want to circle that to make sure you go in the right order. So I have 5 20 seconds. They aren't showing you work here. Okay, it'd be 5 20 seconds times 12, which is 12 over 1. Okay, plus 7 20 seconds times negative 8 over 1. That's the first one. Okay, now remember how my final matrix, this is a 2 by 2, right? 2 by 2 matrix, and this is a 2 by 1 matrix. The only way I can multiply matrices is if the inner numbers are the same, which they are. Like that tells me I can multiply, and the final matrix size will be the two outer numbers, 2 by 1. So this is a 2 by 1, which is what you see then right here. This is a 2 by 1 matrix. 2 rows. Rows come first. 2 rows by 1 column. So 2 by 1. That's my final answer. So I just did the first row times the columns there. I'll get that answer in just a second. Now I'm doing my second row right here. So if I'm going to erase that, now I'm doing this row in that column. So 12 times negative 1/22 is negative 12 20 seconds. I'm just doing it, multiplying those together in my head now. And here I'd have 36 minus, because positive negative is negative, minus 24, minus 36 over 176. Okay. Now I can go ahead and put those fractions on my calculator if I wanted to, or I could take this down to 11ths. That's a 4, and this down to 11ths. And so I have 30 11ths. I'm doing it by hand. Minus 28 11ths. 30 11ths minus 28 11ths is 2 11ths. So you see right there, 2 11ths. They just didn't show all this work. They expect to be able to multiply and add fractions from elementary school. Now I do it again here. Okay, so I can see that 6, let's see, no, let's see, 4 will go into both of those. Hold on. 12, 20 seconds. Okay, and this is just negative 24. I did this wrong. Dang it. Okay, negative 8 over 1 times 3 20 seconds is negative 24 20 seconds. Okay, and I can divide that by 2. Well, I already have a common denominator, so I have negative 12 20 seconds, and negative 24 20 seconds is negative 36 20 seconds, and divide each of those by 2, and you get negative 18 11ths, which is then what this answer is right here. So the x coordinate is the top one, the y coordinate is the bottom one right here. Okay. So the point of intersection is 2 11ths, comma, negative 18 11ths. That's my point of intersection. Remember, when you're solving assisted equations, you're trying to find the point of intersection. And there you go, right there. So you see there's a lot of basic math skills involved here. And now you have 6 problems to do that with. Don't forget, I have to first have them in standard form. So I get the x's and y's on one side, the constant on the other. So 1 through 4 are set up that way already, but 5 and 6, I have to get the x's and y's to the left side, constants to the right side. Okay, and then I can go ahead and do it. You can see, since it takes so much work, that's why you only are having 6 problems to do for this right here. And that will end that.